All right, guys. So we're still on the topic of transformational matrices, and today we are just going to continue and try to wrap up this topic so that we can move on to vectors. So we had looked at 8 transformational matrices. You looked at 4 that involve reflections, and then you had 4 that involve rotation. Now, the reflections, the ones for reflections, we have a reflection in the x-axis, a reflection in the y-axis, a reflection in the line y equal x, and a reflection in the line y equal minus x. All right. Now, generally, those mirror lines, if you were to find them on a graph for the reflection. So just to give you an idea. Now, let's say that this is our y-axis. And this is our x-axis. Now, if you have a reflection in the x-axis, that means the x-axis becomes the mirror line. All right, so if you have your pre-image here, which is a diamond, when it is reflected in the x-axis, it's going to be on the other side of the x-axis. Everybody see that? So it means that the x-axis would be the mirror line. That means if you fall along the mirror line of the x-axis, this image, the diamond, the pre-image of the diamond would fall exactly onto the image of the diamond so that it fits perfectly. All right, so when you're reflecting in the x-axis, this is what happened. The x-axis becomes the mirror line, and your image, when you fold it, should overlap perfectly. All right, now if you're reflecting in the y-axis, that means the y-axis will become your mirror line. So if you're reflecting this diamond above, then if you reflect it in the y-axis, it's going to be on the opposite side of the y-axis. And note that with the image and the objects, or should I say the pre-image and the image, you will find that they will be the same distance apart from the mirror line. And if you draw a line from one object to the next, that line will cut the mirror line at right angle. All right, so any point of the diamond that you label and you draw it to the other point of the image, the same point, that line going to be at 90 degrees to the mirror line. All right. The size of the image and the size of the pre-image will be the same. And the distance from the mirror line will be the same with the image on either side of the mirror line. All right. So we know where to find the image in terms of reflection in the x-axis and reflection in the y-axis. Now, suppose we want to reflect, sorry, oops. That's not what I intended to do, but let me draw back. All right, so this time we want to look at a reflection in the line y equal x. Now the line y equal x will be the line that is straight through the origin at 45 degrees to the horizontal and vertical axis. So this line would be the line. This would be the line y equal X. All right. So if you're reflecting any object within this line, you would have, if you have an object over here, so that like a circle, whenever reflected through this line, it's going to be on the other side of the line. And so if you fold along that line, then your pre-image and your image should overlap perfectly on each other. All right. Now this obviously is not drawn to scale, so this won't be perfect. So this is the line that we are referring to when you're reflecting in the line y equal x. All right, now the line y equal minus x, of course, will be from the other angle. So the line y equal minus x will come along this side, 45 degrees to the x and y axis. And so you should be able to identify these lines when you're doing reflection. So this would be the line y equal to minus x. And of course, if you're reflecting anywhere within this line, and this becomes your mirror line. So if you have, for instance, let's see what kind of object I could draw. All right, so let's say that we have a heart on this side. Then we will also have a heart on that side, not drawn to scale, but this line will become the mirror line. All right, guys. So these are the lines through which the 4 reflection matrices that we looked at yesterday, these are the lines through which the reflections will be carried out. Right? So we can have a reflection with the line X, or in other words, a reflection with the X-axis. We can have a reflection with the Y-axis. We can have a reflection with the line Y equal X. We can have a reflection within the line y equal minus x. And so these are the lines that those 4 matrices, first 4 matrices are referring to. Is that clear, guys? Raise your hand if you understand this so far. Any question? Is it clear to everybody? Are you hearing me? Is my mic loud and clear? Can somebody respond? Ms. Waysome, Ms. Dorothy?
Yes, sir.
Okay.
Sir,
Yes, Ms. Waysome.
I wasn't hearing anything at all because my internet was in and out.
Oh, you're having a connection issue. All right, Ms. Green, how about you? Are you hearing me?
Yes, sir.
Okay. All right, guys. I know you're tired, but just indicate to me when I'm asking you to respond. All right. I just need to know that we're on the same track and that you're understanding. So I'm suspecting that Ms. Waysome was not really hearing much of what I was saying. Are you hearing me well now, Ms. Waysome?
Yes, sir, much better.
All right. Now, by any chance, were you following the diagram that I was drawing?
Sir, yeah, to the point where you were saying when the y-axis would reflect in the y side and the next side, sir. We did follow up to that part, but we did see the one with like the go around a circle, like we never did hear anything for that one. Or slant.
Okay. All right. So I was just merely showing you the lines of reflection for the 4 reflection matrices that we did first yesterday. Right? So we say in terms of a graph, the x and y axis when we say we have a reflection in the x-axis, we mean that the x-axis becomes the mirror line for your image, right? You're following that so far, right? Miss Swayze.
Sure.
And if you have a reflection in the y-axis, then the y-axis becomes a mirror line. So on either side of the y-axis, you have one side you have your pre-image, and the other side you have your image. Following so far, right?
Yeah. Yes, sir.
Right. So this line now that I drew, this line is the line y equal x. So if you have a reflection within this line is what they become the mirror line. So all I was saying about this line, if you have an object reflected within this line, so if you have a circle on that side, this is the mirror line. So this the image is going to be on the opposite side of that line. And so if you fold along this line, it will overlap perfectly. Do you understand that, Ms. Wayson?
Yes, sir.
Right. So this one is the line y equal to x. All right, so when we say a reflection in the line y equal to x, it means that this line is what the mirror line is, right? Now for the other line, where we now have a reflection in the line y equal minus x, that line runs this way, and it is 90 degrees through the 90 degrees to the y-axis and the x-axis. All right. Sorry, I shouldn't say 90 degrees. I mean 45 degrees. So if this line is your mirror line, then what it means then, your pre-image would be on one side and your image will be on the opposite side. So your image will be on one side of this mirror line and the pre-image will be on the opposite side. So if you fold along this line, these two, your pre-image and your image will overlap and fit on each other perfectly well. All right, is that clear, Ms. Waysom?
Sir, this is the one when y equal minus x, right?
Yeah, I'm going to look.
Okay.
Yeah.
Okay, sir.
So this is the line. So this is the line. So this is the line y equal minus x. All right, so when they say there's a reflection in the line y equal minus x, it means that this line is your mirror line. All right, guys, is that clear so far with all of you?
Yes, sir.
Right, so you just now need to know which of the matrices will reflect in which of these lines, right? Now the rotation matrices that we had only gave you rotation for 4 angles. What are they?
Repeat, sir.
The four rotation matrices that you had looked at yesterday. What are the angles that those matrices gave you? 4 angles you got for the rotation.
One is 90.
Right.
180, 360. And a 240, sir, I don't remember.
270. So
Oh, 270.
270, and you have 180 and 360. Now, I can only hope that you guys would have tried to commit those to memory, what those matrices are, what they look like, right? Because I'm not going to go back to the memorizing of those, all right? So for those four matrices, you can use those matrices when you're doing rotation of 90 degrees, 270 degrees, 180 degrees, and 360 degrees, right? Now, in order to rotate any other angle apart from those angles, right? We don't really have any specific rotation matrices for other angles. But what we do, we have a general rotation matrix for any other angles. Now, the general rotation matrix would be this, right? Now, theta here is the angle through which you want to rotate through. So if you want to rotate, I may use this matrix to rotate an angle of 30 degrees. Then what you would do, you would write within this general matrix, you would replace theta with the angle of your desire that you wish to rotate your object or your image to, right? So if you desire to rotate the image, for instance, at 30 degrees from the pre-image, then all you would have to do is put 30 degrees for theta. So instead of having cos theta minus sine theta minus cos theta, for 30 degrees angle, you would have cos 30. So you have cos 30 degrees, and that is actually 30 degrees. Then minus sine 30 degrees. Oops. All right, then down here you would have sine 30 degrees. Over here you would have cos 30 degrees. Now, so once you have put in the angle here now, then you would have used your calculator to find out, write down what cos 30 is. So you put what cos 30 is here, and it should, the same value that you put here going to be the same value that you put here, because this is cos 30, this is cos 30. You find out what sine 30 is. So you put that value here, and then now you put this value here. Anybody know, all right, can you tell me with your calculator what these values are, right? So you have, what I can tell you that sine 30 is 0.5 or a half, all right? So you, over here, you'd have minus 0.5. And cos 30 will be 0.866. Could you check with your calculators for me and ensure that these are correct? Anybody who was assigned to the calculator?
Yes, sir, they're correct.
Right. So what you do, you'd fill in these values in the matrix. And once you put in these values now, you can now use this matrix, multiply the coordinates with this matrix, and then now you would actually have your image based on the result that you get from the multiplication. Is that clear, guys? Is it clear what you're supposed to do if you want to multiply with any angles apart from the 4 angles that were given first? Is it clear to you, Ms. Wason, what I'm saying to do?
Yes, sir, with the costs and the cost and the sign rule.
Well, the ratios. All right, so all I'm saying is that if you are to rotate using any other angle apart from the 4 that we started out with yesterday, then you have to put those angles within this general formula and work out the cost and the sign, put them in the matrix, and then now this matrix, you use it to multiply your coordinates. And this will now give you the rotation of 30 degrees because that's the angle that you put in. If you put in another angle, for instance, a 60, then the matrix would now allow you to rotate your pre-image through 60 degrees and so on. Is that clear, guys? Miss Green, is that clear?
Sir.
I'm not hearing you clearly though, Miss Green. You need to speak a little louder.
Yes, sir. It's clear.
Right. Miss Dorothy, is that clear to you?
Yes, sir.
And Miss Wason again. Is that clear?
Yes.
Right. So this matrix here that we have with the cost and the sign will be the general rotation matrix. And for you to use it in a specific way, you put in that specific angle that you want to rotate your pre-image with by, right? So this is a general. So what you should do is familiarize yourself with the general rotation angle, which should be easy. Along the diagonal, you have cos theta. So from upper left to lower right, you have cos theta. The other diagonal, you would have negative sign up the top, sin theta, and positive sign below along that diagonal. So once you can remember these matrices to rotate by any angle, you plug in the angle here, work out them with your calculator in terms of cos and sine, then take the matrix, multiply your coordinates, then you get a rotation. All right, good. So moving along. So next, what we're going to do now is to look at the exercise here. And this exercise or example has to do with a reflection in the x-axis. Now, anybody remember the general reflection matrix, not the general, the reflection matrix that we use to reflect our pre-image in the x-axis? What's the matrix? Can somebody remind me what the matrix is?
1, 0, 0, minus 1, sir.
All right, good. So here now, what we have up here trying to, let me see if I can just hold this from out of the way. All right. Now, if you look at this question here, it says find the reflection of triangle ABC with vertices 1, 4 for A, and B 1, 3, and for C 1, 4, 3. So these would be your vertices of the triangle. So you know that your triangle, these vertices would be at this where the sides meet. All right, so now if you want to find your image for these letters A, B, and C, then the A, B, and C here would be your pre-image. But if you want to find A dash, B dash, and C dash, then what you have to do to make your life easier, you're going to write these in column form. But when you're writing these in column form, you're going to put all of them in one matrix. All right, so first we write the coordinates in column form. So that's step one. So we write them in column form. So you notice that the x coordinate would be above and the y coordinate would be below. So for A, you have 1 above, 4 below. For B, 1 above, 3 below. And for C, 4 above and 3 below. All right, so this would be your pre-image coordinates. Raise your hand if you're following me so far, guys. Raise your hand if you follow how to write your pre-image coordinates in column form. All right. Now, which axis do we want to reflect this triangle in? Which axis are we reflecting this in? Ms. Wilson.
Which one, sir? The numbers?
Which axis the question is asking you to reflect these
X-axis, sir.
in the x-axis? Right. So first we write the coordinates in column form. So the coordinates of A, B, and C, we put them in column form. That's step one. Step two now is to find that reflection matrix that reflect them in the x-axis. What is that reflection matrix again, Ms. Wilson?
1, 0, 0, minus 1, sir.
All right, so what we are going to do, we are going to multiply this matrix here by that reflection matrix. And so when we're multiplying by the reflection matrix, we are going to pre-multiply by the reflection matrix. What do I mean by pre-multiply by the reflection matrix? Anybody? Ms. Green, what do I mean by pre-multiply by the reflection matrix? Ms. Green, are you able to answer or not? Ms. Doherty, what do you mean by pre-multiply by the reflection matrix? Ms. Wilson?
Sir, put the matrix in front of the one this way.
And matrix in front of the pre-image matrix. Right? This here is your pre-image matrix. And when you pre-multiply by the transformational matrix, you're going to put it in front of this matrix. So when you pre-multiply, you would have this matrix, which is a reflection matrix in that gives you a reflection in the x-axis. We are going to put that in front. In front the what? The pre-image. Now the pre-image is simply A, B, C. Now we're going to multiply through this matrix by that reflection matrix. And then we'll get our image, which is A dash, B dash, and C dash. So these are the coordinates for A dash, B dash, and C dash. Now, what it is that you notice about the coordinates of your image when you compare them to the pre-image? What you notice about the pre-image and the image values, Ms. Wilson?
Sir, one have more values than the other.
When you say more values, what do you mean by that?
Are more rows are 1, 2, 3. More columns, sir.
You sure? Remember your pre-image here. Your pre-image is all of this. This is your pre-image. This is what you're multiplying by your reflection matrix. This is your pre-image.
It has more columns, sir.
By the reflection matrix. This is what you get. This is your image. So I'm saying the two set of values.
Oh, sir, are those two way circle you talk about?
Yeah, those two that are circled. This is the transformation matrix. This is the
Oh,
matrix. So this would not be your pre-image. This is your pre-image that you're multiplying by the transformation matrix. And when you multiply by this reflection matrix, this is what you get, your image. You get what I'm saying, guys?
yes, sir.
So what I'm saying is that you're to look at the results that you get after you multiply by the transformation matrix. Look at what the pre-image was and see if you notice any difference.
Yes, sir. The bottom volumes are all negative.
So what you're actually seeing then is that the two matrices have the same numbers, except that the row in the bottom take the negative of all of the numbers in the pre-image. You follow? Everybody see that?
Yes, sir.
Now, why am I bringing this to your attention? Is to let you know that when you're multiplying by these matrices, it is very easy to multiply by them. So even though you're doing the same row by column thing, you don't even have to go through that long process in your multiplication. You just look at the number down here. This one is negative. That means all of these down here are going to be negative when you multiply. And if you want to check it to make sure that it is correct, you can go ahead and do the multiplication row by column. So you're going to say 1 times 1, give you 1, plus 0 times 4, give you 4. So 1 plus 0, give you back 1, which you get here at the top, right? And if you're doing it for down here now, you use this one. So you say 0 times 1, give you 0. Negative times 4, give you negative 4. So 0 plus negative 4, give you negative 4. So you see, even when you carry it out in the general matrix multiplication, you're still going to get this. So as a way of just observing what the result's going to be, you really don't have to go through the process of carrying out the multiplication. All you have to do is change the sign of the numbers down here. And how do you know when to change the sign down here? You look at